from time to time, we find ourselves wanting to solve for something other than present value or future value. We've already seen how we might solve for an annuity amount in some cases. Right now, we're going to look at a situation where we want to solve for an interest rate. So here's a particular problem. Calculate the yield on an investment producing $1,464 after 4 years, having a present value of $1,000. So the present value is $1,000. The future value is going to be $1,464, and we're going to invest our $1,000 for 4 years. The question is, how much interest are we earning? That's what we mean by what's the yield on the investment, what's the interest amount that we've earned, how much are we earning on this investment. So we can start out by just looking at the equation that would be involved. The present value is equal to the future value discounted for n periods at I interest rate. And we know 3 of the 4 items. We know the present value is 1,000. We know the future value is 1,464. We know n, the number of periods, is 4 periods. We don't know I. Now, we've set it up. We have one equation, one unknown. We have I left. We can solve for I. In order to do that, we have to be able to handle that exponent raised to the 4th. We're going to come back and deal with that at a later point in time. This is the basic setup. For right now, though, let's instead go back to how we would solve this in a table format. So in the table format, relating present value to future value, this is in Appendix A. We have the present values equal to that future value times the present value interest factor. Now, the present value interest factor is coming from a table, and that table has 2 components. It's got an interest rate and a number of periods, I and n. So the first thing we do is we set up the problem to solve for this present value interest factor. And when we solve for the present value interest factor, which is what's been done here, it equals this present value over the future value. You can see how this first equation becomes the second equation right here. Okay, and we find the value of 0.683. Now we take that value. We need to know the interest rate. The interest rate can be found in the table. If we go to the table, we go to Appendix A, we're going to find that when we have 4 periods, we scan across and we find present value interest factor when we have 4 periods corresponds to a 10% interest rate. So we must be earning 10% on our investment for it to grow from $1,000 to $1,464. So this is how we can go about solving for yield. We're going to find that yield in the table. We have to figure out, all right, which table is it that we're wanting to use here, we can do the same thing if we had a future value with a future value table or an annuity table. We just have to find the right formula to use in this form right here. We have to figure out what the relationship is, where that interest factor or interest factor of annuity table, which one we need to go to. Once we find that, we go into the table, we search for the number of periods, and we solve for I. Now, there's a more direct way to do this as well, and we'll talk about that at a later point in time. There's a discussion in the text about interpolating. Sometimes we don't find the value in the table that we want. Instead, the value sits somewhere between. Let's go back here. Let's imagine that we had a value of 0.780, and we knew n was 4 periods. We wanted to find I. We looked for 0.780. We came along the bottom, and we discovered 0.780 sits somewhere in there between 6% and 8%. Is it 7%? Probably not. It's just something between 6 and 8. So how do we go about finding that? Well, one thing we could do is use a method referred to here as interpolation to find the value in the table. Having said that, we're going to skip this. We're going to use a more direct method of finding that value, but we'll do that at the end of the chapter. Okay, we can also find yield when we're dealing with the present value of an annuity. So calculate the yield on an investment of $10,000. That sounds like a present value amount, producing $1,490 per annum. That's the annuity amount for 10 years. All right, the present value of an annuity is equal to that annuity amount times that present value interest factor. We know the present value is $10,000. We know the annuity amount. So present value of the annuity is $10,000. The annuity amount is $1,490. We can solve for that present value interest factor, which is 6710. Then we'll go to the table, use this present value interest factor for the table, and we'll use appendix D. We end up using appendix D. We know N equals 10 years. We're going to find in appendix D the amount that I is equal to, and I don't have that here in front of me. So I look it up here in a table in appendix D for 10 periods, and I find that that equates to an interest rate. The I that gives us 6.710 is 8%.